Now that we've talked about Spring WebMVC and Spring WebFlux, let's compare and contrast them across several different dimensions. And the point of this is so that you can make an informed understanding of what their pros and cons are, and also be able to answer questions from the quizzes. So Spring WebMVC and WebFlux have similarities and differences in terms of both the functionality they provide and also what they use under the hood to implement their semantics. We don't care as much at some level about what's going on under the hood, but it's kind of interesting to know. So if you recall, Spring WebMVC was mostly about imperative programming using object-oriented techniques. Spring WebFlux is about functional and reactive programming using reactive types. The benefit here is that it's relatively simple to write and debug because everything's synchronous for the most part. On Spring WebFlux, in contrast, there's this event loop concurrency model, which we'll take a look at, which is much more complicated under the hood, arguably about the same to program once you understand reactive code and reactive types. Spring WebMVC also has things we've come to know and love, like the Jakarta Persistence API, which is a synchronous way of querying databases using Java types. On the Spring WebFlux side, there's some other things under the hood. There's this thing called Netty, which is done in a more asynchronous way. There's also something we're going to talk about, which I don't show here, but it's part of what we'll be learning, called R2DBC, which is a reactive database model. So it uses project reactor types like fluxes and monos instead of classic Java types like lists and so on. And then some things are still the same. So we have controllers like we did before. There's some underlying stuff used in order to be the web servlet engine. And then you can have reactive clients with either one. So let's talk now about how it works under the hood. So Spring WebMVC is synchronous, built on the servlet API with synchronous I/O. And by default, unless you are clever and integrate in the very modern Java virtual threads, you have a thread pool model where there's one thread per request, but it comes out of a pool. If you use very modern Java and virtual threads, there still is one thread per request that just aren't part of a pool anymore. So that's basically the way things work. We've talked about this diagram before. So when you make requests, what will happen is the requests come in, there's a pool of threads. This is classic Spring WebMVC, of course. And when there is a thread available in that fixed size pool of threads, it's taken off and it does processing. And if the thread has to access blocking resources like a classic JPA-based database call, then the thread will block. So there's all kinds of blocking that's going to take place under the hood here in the WebMVC model. In contrast, WebFlux is asynchronous. And rather than having this pool of threads, it also has a pool of threads, but it's a much smaller pool of threads. So the pool of threads you typically have for Spring WebMVC by default is 200. I think you can configure it, but it's about 200 threads. With Spring WebFlux, you typically have roughly about as many threads in the pool as there are cores. And of course, it can use the blocking elastic if it needs to. But essentially, it's very flexible and much more resource conserving because you limit the number of threads that you have. And each of those threads runs an event loop, and clients will put their requests, they drop their requests off into some kind of asynchronous queuing-like model. And the event loop will take the operations, and when it is ready to do something, when the operations are ready to run or when they complete, because they're all running asynchronously, then callbacks are invoked. And this is what implements the programming model that you see as a programmer of WebFlux, which looks just like you're programming good old project reactor fluxes and monos. So it looks very similar, but under the hood, it's a completely different implementation, and it's using these asynchronous types and asynchronous processing. And all the callbacks are to all the stuff that's happening here is totally transparent to you as a programmer. So the nice thing about Spring WebFlux is it's asynchronous. So requests come in, and there's only a handful of threads in the pool, and the threads will, under the hood, you don't see this, they register callbacks, and they only do operations when things are ready to run. And most importantly, these threads that come in, the requests that come in from the client, are going to return almost instantly back to the client. So the client won't have to sit there blocking, waiting for the processing to finish on the server side. So that's the primary difference. It's an asynchronous model from beginning to end. Now, what you also do here is that WebFlux will pass monos and fluxes as endpoints. You can pass fluxes as parameters. You can return or you can pass monos and fluxes as parameters to endpoint handler methods. You can return monos and fluxes as the results of these endpoints. And so things are happening, but it's all happening very asynchronously. To make this work, they had to add a new type of client programming abstraction. Now, we kind of hide this in a lot of the helper wrappers I've been providing, but what you would see if you're using Spring WebMVC is this something called a REST template. And a REST template allows you to make invocations where you pass in a URL and some type information like classes to know what the return value should be and so on and so forth. So this is kind of the classic REST template approach. And we can use auto-wired ways to integrate all this stuff. With Fluxes, however, you use a different client programming interface or abstraction called the WebClient. And the main difference between a WebClient and REST template is that the WebClient allows asynchronous operations and it returns reactive types. So let's take a quick look. So here you can see that we're going to make a REST template call here, and it's going to block until we get the results back. And if you want to use this approach, if you want to use REST templates, you can use them, but you're not going to get the benefits of asynchrony. Now, what we can do here, this is just if you're absolutely desperate to talk to something that's got classic Java types that block, but you want your clients to be reactive after the calls come back, you can convert the results that come back from a call to a REST template into a reactive type via a model something like this, where you can basically get the results back. This is an array of airport objects, and if we get something back, then we convert that array into a list, and we convert that into a flux, so we can have a flux, or we just give back an empty collection. So you can convert things back and forth, but be aware that this doesn't really give you any win as far as being asynchronous end-to-end. It just gives you client-side reaction once you get synchronous results back. In contrast, WebClient, which is really what you would want to use if you're programming with reactive types in WebFlux, leverages reactive types end-to-end. And so what happens here is we say, make a GET call on the server with this URI and retrieve the results and convert the results into a flux of, in this case, airport objects. And what's nice about this is as soon as anything starts coming back, the client will be able to receive what's being emitted by the server. It doesn't have to block waiting for things to come back. So you can integrate this reactively with the client instantly from the client's perspective. And what's even cooler here is this can work to give you end-to-end asynchrony. This is particularly true if you have a client that supports asynchrony. If you are using Android, it doesn't quite work, but if you're using other clients that are not Android clients that support Spring, you can make it work. So you can have asynchronous communications from the caller to the controller, from the controller to the service layer, from the service layer into the model, which would be the database, the reactive database. And what's interesting about this stuff is even if you do all this code, there's no HTTP request sent at all until the client calls subscribe over here somewhere. So the whole thing is done in a completely lazy manner. Now, that may sound confusing at first, but it really is just the way you write programs with reactive programming. So from the perspective of programming a client, it doesn't really look any different. You can also use the HTTP interface in Spring 6 and beyond in lieu of using WebClient or REST template, which is even better. So you don't actually have to write the code that looks like this. This is the part that's the WebClient get URI retrieve body to flux blah blah blah. You don't have to write any of that. You can simply use Spring 6's and beyond's HTTP client interface mechanisms, and it'll automatically generate you all the things that you need in order to do this. So that's super cool. Under the hood, the encoding and decoding of data that goes back and forth is similar for both WebFlux and the traditional WebMVC types. Not identical, but very similar. So if you understand JSON, it's going to look very similar to that. And therefore, you can use tools like Postman, which are ways of being able to program test endpoints and so on for driving your reactive web services. You can use Postman in order to be able to generate requests, get results back, analyze what was sent and received, and it works seamlessly with either the classic Java types with Spring WebMVC or the modern reactive types with Spring WebFlux. So that's the end of this comparison and contrast. This goes into perhaps more implementation detail than you really need to know in order to use this stuff, but I wanted you to be aware kind of under the hood of what's happening. And it really is a very different style of implementation between the two different stacks.